Lightweight, portable, innovative. TESCO's 6330 meter site analyzer is the most versatile and complete tool for testing the entire functionality of transformer-rated metering installations. Contact us today for a free demo.
So today we're going to be talking about electric vehicle chargers and trends in the marketplace, and we're going to try to take a very broad tour of what's going on. And I hope everyone will ask questions. Just post them in the chat. We'll see them right away, and we should have time at the end. So EV chargers, we call them EVSE, electric vehicle service equipment. Other parts of the world, they call them other slightly different things. There's a tremendous amount of activity going on right now in the US and around the world in terms of writing standards about how they should work and how they should behave. And so things are still in a state of flux about how this is all going to sort out. But in the US, we do have now federal regulations. The first ones will go into effect January the 1st, after a 1-year delay as people sort of got their acts together. And we'll take you on the tour. So there are a lot of different types of EVSEs. Some are more commercially important than others. We're going to talk about that. We're going to talk about what's happening in the marketplace, because if we went back a few years, everyone was saying things were going to happen faster. There's been sort of a dip in what's going on with this last year of COVID worldwide, but it looks like things are about to pick up again. We're going to talk about the regulatory environment, because these are treated like gas pumps, not like utilities. And we're going to talk about type approval and testing. So that's a lot to cover in an hour. Sorry. So we'll move along fairly quickly. Again, if you have a question, pop it up in the chat. So AC standards are well established. They're stable, and except for just 2 variations on connectors, they're the same worldwide. Back in the beginning, there was AC level 1 using J1772. That's primarily for home installations. There are very, very few commercial level 1 chargers, and that's because it's limited to 120 volts at 16 amps. And if you were trying to charge a hybrid with a very small battery, okay, you might get some reasonable amount of charge. Whoops, I'm sorry, I didn't mean to roll the button. But you only get about 5.6 miles per hour of charge. So even if you charge all night, you don't get much charge. AC level 2 is the predominant type of commercial charger. It's 240 volts, theoretically up to 80 amps. But at the moment, the highest capacity of any vehicle to charge with AC is only 40 amps. And a theoretical maximum power delivery of 19.2 kilowatts, but practically 7.2 is as much as anything delivers out in the market. And the reason that it doesn't go higher is that in AC charging, all of the charging circuitry has to be in the car. And car manufacturers just don't want to spend money putting higher power AC charging converters in the car when they view AC as a plug it in, leave it for at least an 8-hour period kind of approach. Okay? Right now, 85% of the commercial EVSEs out there are AC level 2. And every EV or PHEV can use these chargers, though some have to have a small adapter, but it's a very simple adapter. And stations cost about $6,000 a port, including installation to install. So this is the map of AC level 2 public stations. Okay, so this means sites. A lot of sites have a lot of charging ports. So the number of ports is much, much larger than this. Okay, and if we look at the difference between 2019 and 2020, you can see from the map that, there's been a 50% growth in the number of sites and a much larger growth than that in the number of ports available. But remember, if you've got an electric vehicle or even a more modern plug-in hybrid, it takes a long time to fill up the tank on one of these. Okay, the standards are evolving. Here in the US, we use one of the two variations of the combined charging system standard. We use CCS1, which is also equivalent to SAE J1772. Okay, in Europe, they use CCS2. The difference between these is only the connector. Everything else about them is the same. Okay. Japan uses CHadeMO, which is a DC only standard. So if you have a CHadeMO car, you're going to have two connectors on it. You're going to have either a CCS2 AC connector or a CCS1 AC connector, along with the big CHadeMO DC connector. CHadeMO is from Japan, and it's used on things like the Nissan Leaf. Only Japanese cars use CHadeMO. We've got Tesla V1, which is the 50 kilowatt chargers, Tesla V2, which was the 150 kilowatt chargers, and there's a Tesla V3 on the way, which is a 350 kilowatt charger. A couple of years ago, after the U.S. pulled out of the Trans-Pacific Partnership, CHadeMO, which was headquartered in Japan, made a deal with Japan and India. CHadeMO is now headquartered in Europe, and this is a new standard which is called ChAdeMO, and technically it's the best of all the charging standards, and there's a good expectation that in the future we'll see ChAdeMO maybe finally winning out over everything else. So right now, 100 kilowatts considered high end. The very first 350 kilowatt chargers have been installed, but at the moment, there's not a car that can handle 350 kilowatts, though that's coming very, very soon. Okay, deployment's growing rapidly in the US at about a 50% until 2020 compounded rate, but that's actually quite slow compared to Europe, China, and Japan. So this is where we are at the moment. And as I said, this is growing quite rapidly. There's a lot of money going in to expanding the charging network. So here's where the J1772 DC public stations are located. And this was in 2019. And you can see the growth just between 2019 and 2020. About a 75% year-over-year growth. And this is just for CCS. Okay. Here's CHadeMO, and you can see that back in 2019, the CHadeMO map and the CCS1 map looked almost identical. Okay. But as we move into the future, it's grown too. And it's grown in almost identically the same places in the same way. And the reason for that is that most commercial chargers like ChargePoint, EVGo, have two ports on them. One port is CCS1 and the other port is CHadeMO. So when you get a new DC charger, typically it has one of both kinds of ports on it. Okay, and now Tesla. So Tesla has a sort of different philosophy about where they choose to deploy stations. So the number of actual locations is smaller for Tesla. And as we look at how it evolved between 2019 and 2021, you can see the number of sites about doubled, but it was sort of hard to see that on the slide, because when Tesla puts in a site, it typically puts in anywhere from 4 to 16 superchargers at one site. And their philosophy has been a lot more about enabling the Tesla driver to get from point A to point B than just having chargers wherever someone feels that putting in a charger can be beneficial to them, because the Tesla network is a centrally managed, centrally owned, planned network, whereas the other networks are wherever someone believes having a charger is beneficial to them. So different philosophies. Okay, so where's all this going? The market direction is to higher and higher power DC chargers. And the charger, the EVSE manufacturers are out there with the capability of going to higher and higher rates. But the customers aren't there yet because most of the cars haven't quite gotten to be able to use these higher rates. So right now, though there's a big focus, particularly in Europe, on higher charging rates, the actual availability of any significant number of vehicles who can use them in the US is still really low. So this is just a charging time versus kind of charger, and the times are in hours. So, you know, everyone's dream is to getting out here to, 10, 15 minutes. But that takes a lot of power. That's your 400 kilowatt range of charger. Now, the cost to fill up. I was looking yesterday at the charging rates for various DC charging systems. And what I saw was they're typically, this is a little bit older slide, they've moved up considerably. They're typically between about 40 cents a kilowatt hour and $1 a kilowatt hour, depending on the available charging rate from the chargers. And the cost seems to go up rather dramatically with the charging rate capability. Okay, so back in 2015, remember that's only 5 years ago, there were 25 pluggable electric vehicles. One had a range of 200 plus miles. Very few offered DC rapid charge. And if you just go back a few years before that, the number was down to 4. So things have changed a lot. This was in 2018, 2019. I've got some newer slides later on that give an even better idea of how the market has changed. Okay. Today, there's a considerable difference between charging system manufacturers and network operators. These are the prime charging system manufacturers, and whether you talk about it as being AC, DC, or both, then the rankings shift. EVgo and Tesla are the largest manufacturers at this moment of DC systems. ChargePoint is the largest manufacturer of AC systems. And some of these people, in fact, the majority of these people weren't really in the game a few years ago. Now, when it comes to networks, Blink, ChargePoint, Electrify America, which was created out of the Volkswagen lawsuit, EVgo, Tesla, and Volta are the largest networks. Notice some of these aren't equipment manufacturers, they're network operators. So here's an update on cumulative sales of electric vehicles and plug-in hybrid electric vehicles. You can see things through August 2020 have been going up. The rate at which they were increasing, just like the rate of all automobile sales, leveled off a bit in 2020. 2020 was not a good year for the automobile industry. Okay. So here's the percentage of the U.S. new vehicle market as we go from 2015 up to 2020. As you can see, the sales growth has been erratic. People are projecting a much higher percent next year, and that's probably reasonable, especially as some of the market pressures change. So here's a worldwide picture of that. You can see China is where the electric vehicle market has had the most penetration. Europe is very strong. And if you look at Europe by country, some countries, electric vehicles are approaching a 50-50 share. And one of those is Norway. And then the US has got a bit of a different history. 2019 was not a good year in the US, nor was 2020. We'll see what happens in 2021. Okay, so here's EV sales by manufacturer, and you can see that one of the things which has a big effect is the federal tax credit. It caps at 200,000 vehicles sold by a given manufacturer. So some manufacturers still have a way to go to get to their 200,000. Tesla is already there. Okay, and here's a what I think is perhaps the most interesting market-related graph. Here's all of the sales since 2011 broken down by model. Okay, and you can see in 2018 the Tesla Model 3 came out, and what a huge share of the marketplace the Model 3 captured in 2019, 18, and 2019. And I think that's what frightened all of the manufacturers to make major commitments to being in that marketplace. Okay, and just a global look, China, Europe, the US, that's where the real activity is. Okay, so unlike electricity meters, which are exempt from sort of everything because they belong to utilities, electric vehicle chargers are regulated by the Council of Weights and Measures, which is implemented under NIST and Department of Commerce guidelines. So the Council of Weights and Measures regulates how every everything that is sold by quantity is sold within the U.S. And that's done in a document called Handbook 44. And there's a section of Handbook 44 for every kind of commodity, from truck scales to hydrogen as a vehicle fuel. And back in July of 2015, a new section, 3.4, was added to that for electric vehicle fueling systems, okay? Which is electricity sold as a vehicle fuel. And that was tentatively approved in January 1 of 2016. It's remained a tentative standard on a California level. It will go into effect finally as the real standard January 1 of 2021. And it will go into effect nationally January 1 of 2022. Okay, so we're going to talk about that because it's such a different environment than the usual utility environment. So the standards that apply to it are Handbook 44, NIST Handbook 130, which is basically an examination process, and NTEP regulation PB 14. So NTEP is the national certifying agency for any measuring device that is used in the process of selling things that are regulated by Handbook 44. So unlike utility meters, where we have the ANSI standards, and typically utility meter manufacturers self-certify that they've met the ANSI standards, or a utility may actually test things against the ANSI standards. In the world of weights and measures, there's actually a national entity, NTEP, that performs that testing, and which then issues a certificate of compliance, without which you cannot use the device in trade. So very, very different process than utility metering. Okay, so I'm going to go through all the details of how this works pretty quickly. If anyone has a question that I don't cover, please throw it up and we'll slow down and we'll do that. So the code applies to anything that's used to measure electricity dispensed as a vehicle fuel, where you sell it by the amount of energy delivered. And this plays in conjunction with HB 130, which says the only way you can sell electricity as a vehicle fuel is by the quantity delivered. So those two play together to mean that, for example, one of the current common ways of selling charging, which is by the hour, is not permitted when these regulations go into effect. Okay, so what doesn't it apply to? It doesn't apply to a device which is maintained and owned and used by a public utility or municipality only in connection with measuring electricity subject to the authority having jurisdiction, such as the Public Utility Commission. The question has already been asked, well, if we own it and we maintain it, but we make it available to the general public, that doesn't count. That's not under the jurisdiction of a Public Utility Commission. Electric EVSEs used solely for the dispensing in conjunction with operations in which the amount dispensed does not affect the customer charges. So if you give energy away, it doesn't come under the jurisdiction of the Division of Weights and Measures. And finally, for the wholesale delivery of electricity. So charging of buses based on a contract would not be covered by the regulation. That's what I just talked about. So there's been a lot of discussion and a lot of refinement as to what things mean. And basically, if you're selling to the general public or as part of any kind of club or anything that sells energy, you gotta charge based on the amount of energy delivered. And you have to measure it according to the requirements of HB 44. This is changing. California's going full bore January 1, 2021. They're going full bore with DC January 1, 2023. They're already doing type approvals. And federally, we look like we're 1 year behind on the AC, but same time schedule for DC. California changed some of their specific requirements for things like the resolution of the measuring device and the minimum measurable quantities. The National Council has a pending vote on making these same changes in January at the national meeting. This is to be able to speed up testing so that it doesn't take so long for divisions of weights and measure people to do testing in the field, because current requirements are just like these were gas pumps. They have to be tested every year until there's statistical proof that that's not required and a longer test interval can be used. Now, these things sit out in the open, and just like a gas pump, they're supposed to be accurate over a very broad range of temperatures and environmental conditions. And so, just like a meter, during type testing, there's a lot of work that has to be done and a lot of tests that have to be done. And when they're tested in the field, there's not, at the moment, an overall allowance for them not to perform within specification. independent of what the ambient temperature is. They do or may do a no-load test. They want to make sure that the meter, that if you don't draw any power from the EVSE, but you run a charging session, that there's no charge. They have a starting load test at the moment, though that may change. It's likely to change because field testing that's been done shows that there's really no time in a testing cycle for a real vehicle where loads this low are presented, and this test takes a lot of time. So that's probably going to get modified as time goes forward to not require testing down at these low currents, particularly for DC systems, which bottom out at about 10 kilowatts. This is a thing that's been discussed dramatically. It looks like this is going to be pushed down. In the metering world, we often test a meter for just a very few watt hours, and the original draft standard of HB 44 required the minimum delivery to be half a kilowatt hour, and on some of these chargers that takes a very long time. Testing for accuracy is then done at 10% of the maximum deliverable power and at 85% of the maximum deliverable power. That's a lot of power for a DC charger, and the question becomes, what do you use as the load for doing that? We'll talk about that some more, but all of these things are evolving as more and more tests are being done. Same thing is required for DC systems. This again is changing and evolving as testing is being done. For DC system, think of a typical high-end 100 kilowatt system. 10% is 10 kilowatts. That's an easy test to do with totally under control with the kind of test equipment that TESCO provides. And we'll talk about the details of what happens at higher powers and higher voltages in the future when we get down to talking about real equipment. They're required to do repeatability tests. And so, again, that lengthens the time on site to do testing. It's not such a bad problem with DC systems because the power delivery is very high. Tests are very short, but it is a power for AC systems. And remember, at the moment, there are many times more AC systems than DC systems. I have a question from Jeff about how California is going to allow testing. What they've done is, if we go back a few slides, okay, California has changed the requirement for the resolution from 1 watt hour to 0.1 watt hours. And they've given the manufacturer the ability to specify a much lower minimum deliverable quantity. So we've done testing with a variety of manufacturers, and most manufacturers are completely accurate if you move this 500 watt hours down to 50 watt hours or even less. And so if a manufacturer takes advantage of the lower watt hour minimum measured quantity with the 0.1 watt resolution, then yes, you can get your test for full load down to well under 5 minutes, okay? And still maintain the test accuracy. But if you don't do that, you have to test long enough to have enough resolution on the display for the measurement to be a valid measurement. Okay. Test tolerances. The acceptance tolerance at type test is 1%, and the maintenance tolerance, which is what one would test to when you're in the field, is 2%. Just some real world feedback. One of the states has been testing for the last 2 years, and they've only had one manufacturer who fails the 2% tolerance. They fail it consistently and significantly, but it's on the low side, so they're not charging as much as they should. Couple of other manufacturers, one other manufacturer has a couple of quirks under some circumstances, but in general, the systems are looking for AC systems to be pretty good. No load and starting load tests are probably sort of going to go away. It looks like, because nobody seems to have any problems with those, but at least at the moment, they're still there as optional tests. Type evaluations, as I've said, have started. California has started running type evaluations in their laboratory. They have not yet, I don't believe, issued any type approval certificates, but they're working on it. They plan to be issuing type approval certificates before the first of the year. EPO 30, which along with Pub 14, outline all of this, is being locked down now. I'm going to just skip through this because I want to spend a little more of my final time on some more interesting stuff. Okay, so back about 4 years ago, TESCO introduced its first generation of EVSE test equipment. Okay, it's been out in the field. It's been used by various jurisdictions. Whoops, why am I going so fast? It's been used by a variety of jurisdictions to do testing. And we've learned a tremendous amount from the equipment that's been in the field and the experience we've had with it. One of the things that 6 years ago, when I started all of this, that we believed was that the U.S. would be sane and we'd end up with a single charging standard, which everyone expected at the time would be the J1772 standard, because that was a SSA standard. Has not happened. We've got more potential standards now than we had back then. And even within any given standard, we've had multiple revisions so that the details of how CHadeMO works at revision 2.4 is quite a bit different than how it worked at 1.1. And while things are generally backward compatible, what the new chargers do is not at all, in some cases, what they originally did. Okay, so let me show you what's coming. The T4000 is a new product that's coming out next year, and we hope it addresses all of the issues that people have talked to us about in their use of the first generation product. Because there are a lot of standards out there, this product is capable of dealing with any 3 standards at one time. Okay? It can be ordered with different combinations of connectors. We are working to get Tesla to play with us. Right now, they maintain a completely closed ecosystem. So you can't buy a Tesla connector, and they don't divulge their communications protocol in order to make a test system for them. But the weights and measures people are pretty insistent that if they want to sell by the kilowatt hour, which they're already doing some places, once the regulations go into effect, which will be in January of 2023 in California, that they have to be able to be tested. So till then, we can do all the rest of the we'll be able to do all the rest of the standards, but not Tesla. So a suggested question that I ask the audience is, what are people doing? Have any of the people on the call experienced working with EVSEs, and what are your plans for the future? While we're waiting for a response, I'll go on through the last few slides, and then we'll take up that at the end in the question period. So the T4000 has universal test capabilities, as I said. For single phase, it will be able to do CCS1, CCS2, GBT, and Menenquez. That covers everything that is AC single phase. It will be able to do AC 3-phase for CCS2 and GBT. Not really any of that in the US at the moment, but there is a lot of it in certain parts of the world. DC will be able to go to at least 200 amps, probably higher. It's designed to go to 350 amps when connectors are available. So right now, the commercially available connectors are limited to 200 amps, but we've designed the guts of the system to be able to go up to 300 amps when connectors are available. And we'll be able to do CCS1, which is the J1772 Duo that's used by most American manufacturers. We'll be able to do CCS2, which is the European standard. We'll be able to do CHadeMO. We'll be able to do GBT, and we'll be able to do ChAdeMO, which is the new, as I said before, Japan, China, India standard. And when you put those three marketplaces together, they account for probably 80% of the world's marketplace for electric vehicles. Okay? The system, we hope, will be extremely easy to use. We've listened to feedback from our customers in terms of how they wanted it to operate, and we've reviewed this with our biggest current users. They say it meets their needs and solves some of the issues that they've had with the older equipment. It's very easy to set up automated test sequences. It's fully database driven. It provides the real-time information that regulators have asked for. For example, it adds what's the real voltage that the unit is delivering, what's the real current it's delivering in real time, what's the real power it's delivering in real time, okay? And one of the things regulators have seen is that, of course, this varies a lot in DC, but it can vary in AC as multiple people plug into a bank of chargers. So those are things that they asked for to make understanding what was going on in real time easier. They, in fact, have conducted that. It's over. We were there for the test. And everything seems to be going well. NTEP and CTEP both use our equipment for this testing process. That's the end of my presentation. John Carroll, who is our person out on the West Coast, has been working with CTEP and the California Division of Weights and Measures, and he's been at a lot of their last test sessions. So, John, do you want to hop in and say anything?
Yeah, can everybody hear me okay?
Yes.
Thank you, Bill. Really appreciate that. That's a pretty detailed overview and summary of all that's going on. And as you pointed out right from the beginning, this is a moving target almost. It keeps changing, hopefully for the better. And yes, out in California, Jeff has sent us a quick comment that the CDFA has done some training with local county weights and measures. I've been involved in that. It's been extremely interesting watching this develop. And some counties are perhaps a little bit more aware of this than others. So it really will be a question of what the decisions taken within the county level, but we have been approached by quite a few of them. California, to my knowledge, has 58 counties. So each and every one of them at some point will have to consider what to do with their testing program if they want to follow the regulations for 2021. So it's really interesting to find out if there's anyone else out there in other parts of the country that have any comments they'd like to make based on what we've talked about today, because we certainly see a lot of this in California, but I've not seen a great deal elsewhere. Have you seen anything, Bill, any other parts of the country?
Probably it's sort of interesting, probably the most active jurisdiction in terms of actually really doing testing is New York State. They've had a T400 for 4 years now, and they have a full-time person who does nothing but test EVSE sites with it. He's tested hundreds of sites from a wide variety of different manufacturers. And in fact, we just had a conference with them recently to go over their experience so we could learn what they like and what they don't like. And in fact, a lot of the features that you see in the new product have to do with things that they and other of our customers have reported back to us that, oh, this would be nice to have. And so we've tried to add those things into the product and make it really simple for it to be used in the field.
Yeah, certainly in the experience that I went through with Jeff, particularly at CDFA, and his colleague down in Southern California, was timing. With the amount of EV installations, type approval installations, as similar to a gas station, which may have 15, 20 pumps on it, each one has to be tested. So timing is an issue for them. They want something quick and easy. That doesn't take a lot of training. We went through some basic training with them, and they were pretty delighted with the fact that the instrument will take care of the HB44 test for you. That's something they really appreciated, because it will save them quite a bit of time and deploying so many people to have to do this. Can you speak to what the situation would be if you don't do a physical test that meets the requirements? Would that EV charger be disabled, would you say?
Well, just like a gas pump, a gas pump has a seal on it. Mm-hmm. And everybody's familiar with looking at it and seeing the little holes punched in it that says, oh, this was done in June of 2019. Well, an EVSE charger, once things become fully enforced, which for California, for AC chargers will be in January, if it doesn't have a seal, you can't operate it. So it's going to be really important for things to get type approved and get tested by their local weights and measures organizations in order to be used to produce revenue. Because if it's not certified by the state, your only alternative is to give it away.
Yeah. Yeah, that's going to be something everyone's going to have to consider as it starts to develop more and more, and it will definitely do that. Yeah, that's we're at 9:59. I don't know whether anyone else has got any questions they'd like to ask. Okay, well, everyone can follow up afterwards for sure. Andy, I'll hand it back over to you.
All right. Thank you so much, John. Thank you so much, Bill. And I want to say thank you to Jeff for all of his comments and questions in the chat there. You guys don't have to be shy. You can certainly throw something in there. There's Cheryl saying, thank you, Dr. Hardy. Good to hear your voice again. So yes, please do use the chat. We can stay on a few more minutes. I know you guys gave us an hour here. It's almost just about an hour into this. So if you guys have time and you want to hang out and you have questions, certainly throw them into the chat. We'll hang out here a little bit longer. Just let you guys know next week we are going to be doing streetlights and 5G metering and testing. If you've not already registered, you can go to our website and search for the TESCO Tuesdays and sign up. We'll also be sending around our rewind email that'll have both the presentation and the video portion of the presentation, and you guys can find the links on those emails as well. And you can certainly always reach out to us, and we can get you guys signed up or help you guys log on or anything you need. We're here to help you guys. So with that, I guess, Bill, do you have anything you want to add?
No, if anybody has questions and they were too shy to ask, I'll stay on for another few minutes and just unmute your microphone and ask away.
All right. Other than that, thank you everyone for joining us. We look forward to seeing you next week, and we'll talk to you guys then. Thank you so much. Have a great week.
Goodbye, everyone.
Thanks, everyone.
Bill, just while we're waiting, the thing that is kind of an open conversation about DC testing, with these sort of levels of power that we're talking about, how on earth are they going to recapture it? Is it possible to recapture that sort of level of power and reuse it?
That's a really good question. One of the things that we're discussing with both California and with New York is, okay, if you really want to test these next generation chargers at 85+% of their maximum delivery, then you have to have a really big load. And perhaps the only realistic way to do that is to have a battery system that you charge as part of the load. Mm-hmm. And the problematic part of that is that in order to be able to do a full day's worth of testing on a group of high power chargers, you need a really big battery. It has to be several times the size of the battery pack in a high-end vehicle.
Right.
So now you're talking about something that is really, really big and really, really expensive.
Hmm. Yeah. Okay. Well, that's something I'm sure that we'll be thrashing around with in the coming years to see how it goes, because there's no doubt they want to try and emulate the gas station approach, in and out as quick as you can.
Yep. That's where it's headed.
Yeah. I don't know how practical that is going to be, but nonetheless, they're trying to press and press and press and get them down to less than 10 minutes or so, which is extraordinary.
Yeah, and that's going on at exactly the same time that the battery capacity is going up.
Right.
You know, right. If you go back a couple of years, a 60 kilowatt battery in a vehicle was considered huge. You know, now it doesn't get you into the championship round.
No, not at all. No.
Okay. So the batteries are up at 120 kilowatt hours and growing. So,
yeah, it's going to be, there's some physical dynamics people are going to have to consider when they're doing all this. I mean, you know, you can't be hauling around a trailer full of batteries. Just, I mean, you just can't. So,
well, you know, the piece of equipment that they use to test liquid nitrogen, helium as a vehicle fuel is actually a pretty good size truck, substantially larger than a pickup truck.
Yeah, I'll bet it is.
So, it might be that if they really want to test things at that level, you have to build a system into the back of a truck.
Yep. Yeah, that's pretty much how it's going to be. All right, Bill, I don't know whether anyone else is on anymore. I think it looks like.
All right. Yep. I'm going to drop off.
Yeah. Hey, Bill, could you do me a favor? Could you send me that presentation? That's really good.
Yeah. I mean, Andrea has
We can send it to you. Yeah.
and we
yeah,
can send it to you.
Yeah, it's good to update with the updated information on there. It's really useful.
Yeah. Okay. We'll do.
Thank you, Bill. Excellent presentation. Really appreciate it.